In this video, we're asked to determine if two planes are parallel, perpendicular, or neither, and if it's neither, then find the angle between them. The two planes in question are x plus 2y plus 2z equals 1, and 2x minus y plus 2z equals 1. Well, the two vectors will be parallel if their normal vectors are parallel. They'll be perpendicular if their normal vectors are perpendicular. And if neither of those is true, then we can figure out the angle between those by finding out the angle between the two normal vectors. And we'll always use the acute angle, so if you do the dot product of the normal vectors and it turns out to be negative, that would give you the supplement of the angle that you're actually interested in. So you would just make the dot product positive. All right, so in this case, our normal vectors are 1, 2, 2, and 2, negative 1, 2, respectively. Those are just the coefficients off the x, y, and z variables in the equations. Certainly, these vectors are not parallel. I would have to multiply the first one by a 2 to get that component x component to work, but then the y component doesn't work. If I take 2 times 2, I don't get negative 1. And they're also not orthogonal because their dot product's not 0. So the planes are neither parallel to each other nor orthogonal or perpendicular to each other. So if we want to find the angle between these two vectors, or these two planes, it'll be the angle between the two vectors. So we'll do the dot product over the product of the norms. The dot product is 4. Each of the norms is 3, so we'll get 4/9. We do then the inverse of that 4/9 and get 63.61 as the angle between the planes.